Hello my dear students, in the last class I explained about the bars of varying sections, right? Today we will discuss about the principle of superposition. What is this principle of superposition? Sometimes a body is subjected to a number of forces acting on its outer edges as well as at some other sections along the length of the body. See, till now you have studied when the bar is subjected to only one type of the force, that is acting at the outer edge, right? But sometimes what happens, the other forces are acting at other edges also. Okay, in such a case the forces are split up and their effects are considered on individual sections. Okay, if suppose such a case exists, you have to split up the forces and then you have to find the deformation. The resulting deformation of the body is equal to the algebraic sum of the deformations of the individual sections. So, in each individual sections you have to find the deformations by splitting the forces, and then you can add all the deformations together. Okay, such a principle of finding out the resultant deformation is called the principle of superposition. Okay, we will see that how you can write that in the formula. So total deformation, you know that. What is that? PL divided by AE. Okay, here suppose there are different sections, okay, 2-3 sections. Then what happens in this case, suppose if it is A and E, area, cross-sectional area and Young's modulus are same, then you can keep it outside. Then you can find write P1 L1 plus P2 L2 plus P3 L3. Okay, where P1 is the force acting on the section 1 and L1 is the length of section 1 and P2 L2 are corresponding values of section 2 and so on. Okay, so total deformation can be calculated by considering the algebraic sum of the deformations of the individual. Let us take one example. A steel bar of cross-sectional area 200 mm square, okay, is loaded as shown in figure. Find the change in length of the bar. Take E as 200 GPa. Okay, this is the given problem. You can see here, see the problems like you can see one load force is acting here 50 kilonewton tensile force, and here 30 kilonewton, and here it is again tensile force 20 kilonewton. Okay, so all are different. Okay, here, so how you can calculate this? See, first only I have told, when you consider the deformation, that P, it has to be same at both the sides. It has to be subjected to same tension or same compressive force. Okay, so first we will see what are the given data. Steel bar cross-sectional area is given 200 mm square and modulus of elasticity is given 200 GPa. So convert into millimeters, Newton per millimeter square. It becomes 200 into 10 raised to 3. Okay. For simplification purpose, how you can do, right? See here, this is the given figure, right? It is given like this. Okay. Now you have to split up the forces. How you can do that? See, this force is 50 kilonewton here. This is 20 kilonewton. This is 30 kilonewton. So, the force of 50 kilonewton acting at A, it may be split up into two forces of 20 kilonewton and 30 kilonewton. You may ask, why only 20 and 30? Can take 10 and 40 also. Right, but it is not possible because we have to see the proper combination. Suppose now I divide this 50, 20 and 30. Then what happened? Here 20 is there. So here you can consider 20. The remaining at A is what then? 30. So that A and this C becomes 30. So that combination you can take. So like that you have to think why split the forces. Think properly how you can adjust with the other force. Okay. See now first this is 50 kilonewton. This is 20 kilonewton. This is 30 kilonewton. Suppose I consider this section AB. I will consider this AB bar. So this is 20 kilonewton. Okay, you cannot change into 10 and 10 because there is no 10 kilonewton acting at all in anywhere. But this 50 we can divide it into 20 and 30 because if this 50 divided 20, that 20 if I consider here, then remaining 30 I can consider here at A. And also at C the force is acting 30, so I can consider this bar A to C, that is 30. Okay, so how you can split? Now it will be seen that part AP of the bar is subjected to a tensile force of 20 kilonewton and AC is subjected to a force of 30 kilonewton. Now see here, this tensile force is at both the sides it is same, that is it is 20 kilonewton. Here also it is 20 kilonewton. So now you can apply the formula. Total deformation is equal to PL divided by A into E. That's why always you have to make sure that both the sides, that force or that tensile force or compressive force, it should be same. Okay. So this is done AB. Next consider at A it is 50 kilonewton load is there. Here you consider only 20. So the remaining 30 is left out. That you can consider with this C. Okay. Now at A 50 kilonewton, when you add you have to get the same load. At A 20 plus 30 50. At B only 20. At C it is 30. So like this you can split the forces. Okay. Next step is easy. What is that? You have to calculate the deformation. How you can calculate the deformation? Deformation is equal to PL. Here two sections are there. So P1 L1 divided by A1 E1 plus P2 L2 divided by A2 E2. But here AC is same because it is of uniform cross section. Cross sectional area is given, it's same, and even E also same. Young's modulus is same. It is that bar is made up of same material. Okay, so 200. So you can keep it outside. A into E. Then remaining is P1 L1 plus P2 L2. So first 1 divided by A is 200 mm square into E is 200 into 10 raised to 3. Okay, into P1. P1 is first we will consider this is the first section 20 into 10 raised to 3 into L1. L1 of this A to B, that length is 300 mm. Okay, consider that 300 mm plus P2. P2 is what? That is this 30 kilonewton. Here, this 30 kilonewton. This both are tensile force, so sign is plus. So plus 30 into 10 raised to 3 into, now what is the length? Now A to C length you have to consider. What is A to C length? That is 300 plus 500 is equal to 800. So total length is equal to 800. Okay. So when you simplify this, you will get 0.75 mm. So like this, you can find the deformation by splitting the forces. So this is called the principle of superposition. Means if the forces are acting at the outer edges also and inner sides also, then you have to make that, you have to split the forces, and then you have to consider that you have to find the deformation. Okay, then you can add, take the sum of the deformation from all the sections. So next class we will solve one more problem. You will understand properly. Okay, thank you.